Welcome back. I hope you guys had a great weekend. And as we start this last full week of your senior year, wow, that's kind of crazy to say. Just in case you know, just some housekeeping things. We have today, we have Wednesday, and we have next Wednesday. Next week is the last full week of classes for seniors, and seniors Oh, sorry. Next Monday is Memorial Day, and next Friday we just don't have classes, so that means work is not going to be posted those days. So it's really just next Tuesday, Wednesday, and Thursday, which you're going to have to do work, and your grades need to be straight by June 1st. So whether it's this class or other classes, I just want you to know that that is 2 weeks away to the day. 2 weeks from today is when your grades have to be perfect in all your classes. So that being said, today I want to talk about more advanced charts and concepts. What we're going to do is, this is the last little thing we're going to do before the assessment that's going to happen on Wednesday. I'm going to talk about that at the end, and yeah, I'll talk about that at the end. So let's keep this moving. Of course, they can become more complicated. Well, it's not so much that they're more complicated. It's that you have to really be able to understand how all these values connect, how everything really relates in terms of this. And if you really do, if you really understand how everything here is connected, then this actually seems easy and redundant. So I want to go through and show you how to do a chart that's just a little bit more complicated. In this chart, the mass is not given. We do not know what the mass is. That's a question mark. The other charts we did last week, we knew the mass. But like with our roller coaster stuff, we can use the other information we have to solve for the mass. So how are we going to do that? Well, geez, there is not a lot of information on this chart. We have the initial velocity and the displacement. By the way, the displacement will always be 0 at 0 seconds. That's always going to be, because that's where it starts. It starts at 0 seconds. And displacement is defined as the distance you are from your starting position to ending position. I think that threw a lot of people the charts last week. Displacement, you cannot forget the definition, is the distance from where you start to where you end. Okay. We are going to assume that this is always a situation of dropping, like you're dropping an object and it's falling. So we know it's being pulled down by gravity. Gravity is -10. So we can look at this velocity. If we know any of the velocities, we can figure out the rest, because we know that every second it's getting pulled down by gravity. Gravity is -10. So this is going to be -22, -32, -52, excuse me, 42. I'm so sorry. 52 and 62. Done. So those just remain constant. It always changes by -10. That is a constant. So it doesn't matter what the starting number is. You just keep minusing 10 from it. Okay? So whether it's positive, negative, you just keep minusing 10. In this situation, it's almost as if little Susie is throwing the ball down the cliff. So she threw it down 12, and then gravity sped it up as it fell down. Okay, so that's what's happening there. Okay. I don't even know how high the cliff is. I don't have that. I know that its height at 3 seconds is 161, but that's not necessarily helpful. So what can we do? We have to find the mass. Oh, but check this out. Check that out. If I have the KE and the velocity at one point in time, in this case at 4 seconds, I can use the KE equation to go ahead and solve it out. What do you mean by that, Pizzuto? Well, plug it in. 2, 1, 6, 3, 2 equals 1/2 m 52 squared. Now, it's negative 52, but that doesn't really matter here because whenever you square a negative, it becomes positive. So I'm going to do 52 times 52, or negative 52 times negative 52, and that's going to be 2704. And I said you can take half of that, divide it by 2, and then what happens is it becomes 1352m equals the KE. I'm out of space here, but we've done this calculation so many times before. I trust that we know how to do it. And if you don't, please join me for office hours. But all I'm going to do is divide, and I get a mass of 16. So just like with the roller coasters, you can use a spot where you have a velocity and a KE, or a height and a PE to solve for the mass. It works exactly like the roller coasters. It's not different. So we had a height, actually we had a KE and a velocity, so we were able to solve for the mass there. Okay, because we're just kind of short on space in this place, I'm going to erase that work. But just so you know, that's how it works. Now, I have to be able to find the TE. Just like with the roller coaster problems, you find the mass first, and we have to find the TE. And if I can find the TE somewhere, I have the TE everywhere because the total energy never changes. So, where am I going to be able to find the total energy? Oh, geez. Your gut instinct is like the very first spot. The very first spot, you have a velocity, but you don't have a height. Without a height, you can't get a PE. Look at 3 seconds. At 3 seconds, you have a velocity and a height. So I can use this velocity to get the KE. So I'm just going to use the KE equation of 1/2 mv squared of 1/2 times 16 times negative 42 squared. And I know that a negative squared becomes positive. So I'm telling you that the KE here is 14112. That's the kinetic energy there, 14112. What's the potential energy there? Well, the potential energy there is going to be mgh, mass times gravity times height. You know what? Let me even put it. Potential energy is mass times gravity times height. Kinetic energy is 1/2 mv squared. Hopefully we know those by now, but if not, there you go. So I'm going to do mass, which is 16, times gravity, which is 10, times height, which is 161. Oh, check this out. Nice. I got the potential energy. I can add that with the kinetic energy to get the total energy. So the total energy is 39,872. Do you see how we got that? We calculated for the PE and the KE and we added up. So I know that this 39,872 is going to be, for all of them, the total energy never changes. The total energy never changes. So I can't get the displacement yet, because remember, displacement is the difference from where you start to where you end. Because I don't know where I start, I can't get the displacement. So this is what I'm going to do. Let's look up here. You see how it says negative 12? I can get the KE with that. Let's do it. 1/2 16 times 12 squared. So the kinetic energy here is 1,152. Now I know that this plus this has to equal this, which is the 39,000. So I'm going to do 39,872 minus 1,152, and I'm going to get that the potential energy here is 38,720. This is the stuff we've done before, so if you're confused about how I got this or why I'm going so fast, look at the old videos just to see that at every spot the PE plus the KE equals the TE. Okay? So if you can get one of them, you have the other. So how can I get the height? Oh, with this potential energy, I can get the height. I can get the height. Let me show you how to do that one. That one's just a little tricky, so I will put that up here. So PE equals MGH, 38,720 equals 16 times 10 times H. So when you solve that out for H, and again, we have done this calculation before, so I do not want to necessarily go through that. You will get 242 meters. So that's the height. Now, how can you get the displacement from a height? So to get the displacement, displacement is the distance from where you were to where you started to where you ended up. So you can treat it like this. You could do height of where you are minus starting height. So now that we know our starting height, is 242, we can do 161 minus 242, and we get negative 81 meters. Do you see how that works? From 242, you went down 81 meters to get to 161. That's it. That's it. So what you can do is you can use the velocities to get the KE. You can subtract the KE from the TE to get the PE, PE to get the height, height to get the displacement. I am not going to mathematically solve out all of the others because it works the exact same way. You just, like, let's look at 4 seconds. I'm not going to solve it all, but I will do this one a little bit. 39,872 minus 21,632. So we know here the potential energy is 18,240. We know that. So I can use that to get the height. Plug it into the equation, divide, and I get a height here of 114. Wait, so how did you do that? I did this equation up here. But instead of putting in the 38, I put in the 18. And then how do I get the displacement? How do I get the displacement? I'm going to take my height, which is 114. I'm going to subtract the starting height, which is 242. Oh, negative 128. There you go. That's it. So you can fill in the rest of the chart using this process. It all works the same. It is a giant puzzle. That's all you need to know. So, your last assessment of the year was going to be assigned on Wednesday. Now, I haven't fully decided how long I want to have you do it. I'm going to give you a full week to get it done, but I will let you know. When you start this assessment, the one that's going to be given on Wednesday, it will lock your Chromebook. I'm going to set it so that it locks your Chromebook. That means you won't be able to access other windows on your Chromebook while the assessment is going on. So if you have been used to looking at the PowerPoints, maybe you need to have your phone out so you can look at the YouTube through your phone while your Chromebook has the assessment up. Or I recommend write down what you think you need to know. Write down what you think you need to know on a piece of paper and look at it as you take the assessment. You can write down definitions, keys, remember about what you need to know about positives, negatives, units. You can write all that stuff down. So It's going to be on Google Forms. The answers are going to be realistically right or wrong. I recommend you use scratch paper and you take your time. I'm not going to give you a time limit, so take your time to do this out. It's going to be just from calculating PEs out, everything we did with energy, up until now. So you might see roller coaster, you might see a chart, you might see just calculating PE, calculating KE, calculating TE, looking for the mass or velocity, maybe little Susie walking on a tightrope, a roller coaster problem, concepts. When the PE goes down, the KE goes up. Might ask some roller coaster simulation questions. It's all going to be there. But you got it. And this is the last assessment that you will do for me for the year. So I will give you the time that you need. I recommend that if you start it, please try to, like, I know things can come up, but like, don't start this knowing that you have to leave the house in 15 minutes. That's not a good look. You're not going to do well. So find a time where you're going to sit down, like, all right, I know I should be good. I should, have a couple of, I have enough time to just sit and get it done. So take the time to get it done. Good luck. And I will be here if you need it. And we are about to wrap this whole thing up, which is crazy. Good luck, you guys. I will see you guys next time.